Hi, welcome back. So last time we discussed the importance of integrating factor and how can we come up to find the solution by using this integrating factor to solve our first order differential equation, right? But last time we make our form in terms of m as a function of x and y, dx plus n as a function of x and y dy. But in this topic, we are concerned with equations that are easily for us to discover our integrating factor by only inspecting the given differential equation. Okay, so last time we have a certain formula or technique in order for us to find the integrating factor, but in this topic we will gonna we're gonna find the integrating factor only through by inspection. Okay, and in order for us to easily identify our integrating factor by inspection, we need to identify first some certain exact differentials. Which this can help us to simplify our problems in determining this integrating factor. Okay, so once again, our technique here is to find the integrating factor only through inspection, but for us to easily inspect our integrating factor, the identification of certain exact differentials will help us simplify our problem. So what are these exact differentials? So here are some examples of exact differentials. So say the derivative of the xy is, of course, from the product rule. So we have the first times derivative of the second plus the second times the derivative of the first, which is the x, right? Did you remember this? We have the first times derivative of the second plus the second times derivative of the first. So the derivative of xy is just first times derivative of the second, which is dy, plus y times the derivative of the x. So another, say we have x squared y cubed. So what is the derivative of this? So the derivative of this is, we have first times derivative of the second, right, plus the second times the derivative of the first. And simplifying this, we have 3x squared y squared dy plus 2x y cubed d of x. Okay, so here is the what you call the samples of exact differentials. Another exact differential, say this one, x e to the y, and the derivative of this is first times the derivative of the second plus the second times derivative of the first, it's dx. Yeah. Okay, so another sample of exact differential, say we have the x squared cosine y. So the derivative of this is first times the cosine y, which is sine y dy, plus the second we have cosine y, cosine y times the derivative of the first 2x dx. Okay, then simply we have negative x squared sine y dy plus 2x cosine y dx. Okay, so last example for this exact differential. Say we have how about the x over y. So our rule for this is we have the denominator, which is the low, times the derivative of the high, minus high times derivative of the low over low y squared. Okay, say we have this exact example. These are some examples of exact differentials. Okay, so say we in our given differential equation, we've noticed this kind of term or kind of form, then we can easily see that this whole term here, x dy plus y dx, is this exact differential. Okay, and many more. Okay, so inspecting or identifying this kind of exact differential here can help us to found our integrating factor by inspection. That's why this topic is called the integrating factor found by inspection. Okay, so on the next video, we're gonna try to solve and try to find out the integrating factor only by inspection, by identifying these exact differentials. Okay, I will show you how on the next video. So see you.